we are just discussing about the reaction intermediates. Okay, we have studied introduction of carbocation. That means what is meant by carbocation, some properties of carbocation, etc. Then second point मध्ये आपण काय पाहिलं, structure of carbocation. What is the hybridization of central carbon, how it forms 3 sigma covalent bond, and what is the geometry and bond angle in the carbocation. While third जो point आहे generation, यामध्ये आपण पाहिलं how the carbocations are generated by using alkyl halide, by using alkene, by using diazonium ion, by using acyl halide, etc. Now let us see next point, stability. Very important point, stability of carbocation. Actually here we are going to discuss comparative stability among some of the examples of carbocation. There are different types of the effect which influence the stability of carbocation. For example, inductive effect, hyperconjugation effect, then steric effect, and also aromaticity. That different types of the effect influence on the stability of carbocation. Let us see first one. We will see how that inductive effect influence on the stability of carbocation. Take some example. Look, a simple example. Suppose carbon is attached to the 3 hydrogen, and if it having positive charge, it is called methyl carbocation. Then second example, suppose 1 hydrogen is replaced by methyl group, it becomes primary. This is example of primary carbocation. Second one is the primary. Again, 2 hydrogens are replaced by 2 methyl group, it becomes secondary carbocation. While if 3 methyl groups are attached to the central carbon, it becomes tertiary carbocation. Okay, these are the some examples of carbocation. Now let us see comparison between first and second. Now in the primary carbocation, central carbon having positive charge, it having only 6 electrons in its valence shell, means central carbon is electron deficient. Here central carbon is electron deficient. Okay, what's about the methyl group? What's about the alkyl group? This alkyl group shows electron donating inductive effect. This alkyl group shows electron donating. म्हणजे काय होतं, हा alkyl group, methyl group आणि central carbonच्या मध्ये जो bond आहे, means there is an electron pair. This methyl group donates this electron pair. It pushes that electron pair towards central carbon. This is called electron donating inductive effect. This is called plus I effect. In primary carbocation, central carbon is electron deficient, while methyl group shows electron donating inductive effect. Therefore, that carbocation becomes stable. It becomes more stable. Why it is more stable? कारण जर सेंट्रल कार्बन कडे इलेक्ट्रॉनची कमतरता आहे आणि अशा वेळी आपण जर एखादा इलेक्ट्रॉन देणारा ग्रुप त्याला जोडला, then it becomes more stable. Hence that primary carbocation is more stable than methyl carbocation. In methyl carbocation there is no plus I effect. Therefore that's primary carbocation is more stable. Next example आपण बघूया. In the case of secondary, there are 2 methyl group. Secondary मध्ये 2 methyl group आहे. Again they shows plus I effect. There is a more electron donating inductive effect. Therefore secondary carbocation again more stable than primary. It is more stable because there are 2 methyl group. There is a more plus I effect. Hence it is more stable. What's about the tertiary? In tertiary there are 3 methyl groups attached. Again there is a more plus I effect. All the 3 methyl group, they shows electron donating inductive effect. Hence there is a more plus I effect. Hence it is more stable than secondary as well as primary carbocation. And thus tertiary carbocations are always more stable than secondary, which is more stable than primary, and which is more stable than methyl carbocation. Thus as the plus I effect increases, as the plus I effect increases, stability of carbocation also increases. Okay, now let's see some more examples. Okay, this is the N-propyl carbocation, and another one. Okay, here suppose that methyl group is replaced by, I will replace that methyl group by nitro group. Now what's about this alkyl group? This alkyl group shows electron donating inductive effect. It shows plus I effect. Therefore it is more stable. Yes. Okay, now what's about this compound? Here that nitro group, there is a NO2 group, and we know that nitro group shows minus I effect. It do not having electron donating, पण तो कसा इफेक्ट दाखवतो? इट शोज इलेक्ट्रॉन विड्रॉइंग इंडक्टिव्ह इफेक्ट. म्हणजे तो काय करतो, याकडचे इलेक्ट्रॉन पेअर स्वतःकडे ओढतो. इट शोज मायनस आय इफेक्ट. अँड we know that central carbon atom actually it having electron deficiency, आणि मग इलेक्ट्रॉन डेफिशियंट असेल आणि त्याकडून जर आपण इलेक्ट्रॉन विड्रॉ केला तर इट बिकम्स अनस्टेबल, म्हणजे त्याची स्टॅबिलिटी ही कमी होते. अँड देअरफॉर दॅट सेकंड वन इज द लेस स्टेबल दॅन फर्स्ट वन. This is due to the minus I effect due to the NO2 group. Okay, this is about the role of inductive effect on the stability of carbocation. We have studied how that inductive effect plays a role in the stability of carbocation. Okay, let us see next one. Yes, hyperconjugation. Again, a very important concept related to the structure and reactivity of the organic molecule. Now, what is meant by hyperconjugation effect? First, tell me, what is the hyperconjugation effect? Suppose there is a release of electron from the CH bond, and if that electron goes towards electron deficient carbon, and that concept is called hyperconjugation effect. Consider example, a very simple example. This is tertiary carbocation. In tertiary carbocation, the central carbon is attached to the 3-methyl group. Okay, this is alpha hydrogen. Central carbon पासून पहिला जो आहे, yes, it is alpha carbon. This one is also alpha carbon. This one is also alpha carbon. Okay, now this is alpha CH bond. यामध्ये alpha CH bond जो आहे, काय होतं, दिस बॉन्ड अंडरगो ब्रेकिंग, या बॉन्डचं ब्रेकिंग होतं, अँड द इलेक्ट्रॉन पेअर विच इज प्रेझेंट इन द CH बॉन्ड इट गोज टुवर्ड्स इलेक्ट्रॉन डेफिशियंट कार्बन. इलेक्ट्रॉन डेफिशियंट म्हणजे सेंट्रल, इट हॅव्हिंग पॉझिटिव्ह चार्ज, मीन्स इट इज इलेक्ट्रॉन डेफिशियंट. देअरफॉर दिस बॉन्डेड इलेक्ट्रॉन पेअर आफ्टर ब्रेकिंग दिस इलेक्ट्रॉन पेअर गोज टुवर्ड्स सेंट्रल कार्बन, इलेक्ट्रॉन डेफिशियंट कार्बन, म्हणजे इथला बॉन्ड ब्रेक होतो अँड देयर इज अ फॉर्मेशन ऑफ न्यू बॉन्ड बिटवीन दॅट टू कार्बन. दोन कार्बनच्या मध्ये इथं नवीन बॉन्ड तयार होतो. And while what's about the hydrogen? That hydrogen acquires positive charge because during the bond breaking, electron pair goes away from the hydrogen, hence it acquires positive charge. While there is a pi bond between that two carbon, and we get the another structure, and this is called hyperconjugation. That concept is called hyperconjugation. Actually, there is a release of electron from the CH bond, and that electrons goes towards electron deficient carbon. There is a delocalization, and we get the hyperconjugation structure. Okay, this is the hyperconjugation structure. How many hyperconjugation structures are possible? There is a release of electron from this CH bond. Now this carbon again having two more CH bond. There are two more CH bond. Also, there is a release of electron from that another CH bond, and we get another hyperconjugation structure. Similarly, there is one more methyl group, म्हणजे इथे 3 हायड्रोजन आहेत, म्हणजे 3 CH बॉन्ड आहेत, त्यातले इलेक्ट्रॉन्स रिलीज होतात. That electron pair also goes towards electron deficient carbon. We get same type of hyperconjugation structure. त्यानंतर इथे methyl group आहे, means there are 3 CH bond. Again, there is release of electron from that 3 CH bond, and there is again formation of new hyperconjugation structure. Means similar to this one. Totally, there are formation of total 9 hyperconjugation structure. कारण total 9 CH bonds आहेत, 9 CH bonds आहेत, म्हणून तिथे totally 9 hyperconjugation structures तयार होतात in the case of tertiary carbocation. Okay, let us see next example. Okay, this is secondary carbocation having 2 methyl groups attached to that central carbon. Here also there is a release of electron. इथे सुद्धा electrons release होतात CH bond मधले. There is a formation of pi bond between two carbon. Hydrogen acquires positive charge. This is the pi bond between two carbon. We get hyperconjugation structure. मग या केस मध्ये टोटल hyperconjugation structures किती मिळतील? In the case of secondary, how many hyperconjugation structures are possible? Total there are 6 alpha hydrogen. Therefore, only 6 hyperconjugation structures are possible for this secondary carbocation. यासाठी total 6 hyperconjugation structures possible आहेत. Let us see next, primary. Okay, this is primary having only one methyl group attached to central carbon. Again, there is hyperconjugation structure, म्हणजे CH bond release break होतो, त्यामधले इलेक्ट्रॉन्स या ठिकाणी pi bond तयार करतील, हायड्रोजन acquires positive charge. We get same type of hyperconjugation. Okay, here there are only 3 hydrogen, alpha hydrogen. Hence, there are only 3 hyperconjugation structures possible for this primary carbocation. Thus, similar to the primary, secondary, and tertiary, we are having different types of hyperconjugation structure. आणि एक लक्षात ठेवा, during hyperconjugation, there is a delocalization of electron, and hence that species becomes stable. That species becomes stable due to hyperconjugation effect. More is the number of hyperconjugation structure, more is the stability. More is the number of hyperconjugation structure, more is the stability. Okay, now what's about that primary, secondary, and tertiary carbocation? Which is more stable? Tertiary is more stable because it having 9 hyperconjugation structure. Hence, tertiary is more stable than secondary, which having 6 hyperconjugation structure, and which again more stable than primary, which having 3 hyperconjugation structure. Thus, on the basis of hyperconjugation structure, we can explain the stability of primary, secondary, and tertiary carbocation. We are just discussing about the stability of कार्बोकॅटायन आणि यामध्ये आपण पहिले 2 महत्त्वाचे कन्सेप्ट स्टडी केलेले आहेत. इन्फ्लुएन्स ऑफ इंडक्टिव्ह इफेक्ट as well as hyperconjugation effect on the stability of carbocation. Now let us see third one, influence of resonance effect. Now consider a simple example, a very simple and interesting example. Allyl carbocation, CH2 double bond CH, single bond CH2, and that terminal carbon having positive charge. Okay, this is allyl carbocation. Now here what happens, that terminal carbon having positive charge means it is electron deficient. Therefore, this pi bond undergo delocalization. What happens here? This pi bonded electron pair goes towards electron deficient carbon. Means this pi bond undergo breaking, and there is a formation of new bond between these 2 carbon, while that first carbon now acquire positive charge. And due to that delocalization, that allyl carbocation is more stable. म्हणून हा more stable आहे. Generally, if there is a delocalization, then that carbocations are more stable. And here also, allyl carbocation is more stable because there are 2 canonical structures. Let us see another example. Very interesting example. This is benzyl carbocation. CH2, that's carbon having positive charge. There is one phenyl group attached to that carbon. And here, that carbon having positive charge, there is unsaturation. There is a conjugation adjacent to that positively charged carbon. And here, that pi bonds undergo delocalization. That here this pi bonded electron pair goes towards electron deficient carbon, and we get the canonical structure, we get the resonating structure. Here this is new pi bond. What's about this carbon of aromatic ring? This carbon acquire positive charge. This electron pair goes away from this carbon, hence it acquire positive charge. Okay, we get the first canonical structure. Again, there is a delocalization of electron. This pi bonded electron pair, किंवा हा pi bond जो आहे, it goes towards electron deficient carbon. म्हणजे इथला bond इथे shift होतो. And here, this carbon now acquire positive charge, and we get the another structure. Okay, here there is a positive charge on the para carbon. Now again there is a delocalization, means that pi bonded electron pair shift towards positively charged carbon. म्हणजे इथले electron pair इथे shift होते. Now this carbon acquire positive charge, and we get one more canonical structure. Here positive charge at ortho position, and thus here delocalization of electron observed, and we get number of canonical structure, and therefore that benzyl carbocation is more stable. Totally there are 4 canonical structures for benzyl carbocation. There is maximum delocalization, and hence it is more stable. Okay, लक्षात ठेवा, जर कार्बनवर पॉझिटिव्ह चार्ज आहे आणि ऍडजस्टंट पोझिशनला इफ देर इज अरोमॅटिक रिंग, इफ देर इज अ बेंझीन रिंग, then that carbocation becomes more stable, and this is due to the resonance effect. This is due to the delocalization of electron. Okay, now let us see one more example, very interesting example. Suppose central carbon is attached to the 3-phenyl group. That central carbon having positive charge, and it is attached to the 3 benzene ring, and this particular compound is called triphenyl methyl carbocation. That species is triphenyl methyl carbocation. Now, what's about the triphenyl methyl carbocation? Is it more stable or less stable than benzyl carbocation? In benzyl carbocation, carbon is attached to the only one phenyl group, only one benzene ring. There is a more delocalization, it having 4 canonical structure. Here there are 3 phenyl rings. Therefore, totally there are 12 canonical structures. There is a more delocalization. यामध्ये 3 benzene ring आहेत. There are 3 phenyl groups. Therefore, there is again more delocalization, and we get total 12 canonical structures for triphenyl methyl carbocation. Hence, it is more stable. आणि म्हणून त्याची स्टॅबिलिटी सर्वात जास्त असेल. This is the stability order. First, triphenyl methyl carbocation, it is more stable than benzene. तो benzene पेक्षा जास्त असेल. Benzene is more stable than allyl carbocation. Already आपण allyl carbocation सुद्धा पाहिलं. It having 2 canonical structure. Benzene having 4 canonical structure. Triphenyl methyl carbocation, it having 12 canonical structure, and it is more stable than simple alkyl carbocation. This is just about the stability order. We have studied how that resonance effect, how that inductive effect, how the hyperconjugation effect plays a role in the stability of that carbocation. Okay, now let us see last concept, aromatic carbocations. What's about the aromatic carbocation? Aromatic carbocations are highly stable. They are highly stable. Even they are found in the solid state. Carbocation, it formed in the solid state, and this is due to the high stability of that aromatic carbocation. Consider a very simple example. Why they are stable? Because they are aromatic. They having maximum delocalization. They obey Hooke's rule, means there are 4n plus 2 pi electron, and hence that species is more stable due to aromaticity. Consider a simple example, tropylium cation. Okay, this is the tropylium cation. Actually, total number of carbon atoms in the cycle 1, 2, 3, 4, 5, 6, and 7. There are total 7 carbons in the cycle, as well as there are 1, 2, and 3 pi bond. त्यामध्ये 3 pi bonds आहेत, while 1 carbon acquires positive charge. Okay, this is the tropylium cation. Now, all the carbon atoms of tropylium cation, they lies in a single plane. That compound is a cyclic in nature. म्हणजे तो cyclic आहे, planar आहे. How many pi electrons are there? Yes, there are 6 pi electron. There are 6 pi electron, means it having 4n plus 2 pi electron. And also there is a delocalization of electron. इथं पॉझिटिव्ह चार्ज असल्यामुळे त्या ठिकाणी मॅक्सिमम delocalization होतं इलेक्ट्रॉनचं, and hence that species is aromatic in nature and it is solid also. Tropylium bromide is a solid. आणि आणखीन एक गोष्ट लक्षात ठेवा, it is about 10⁻11 times more stable than triphenyl methyl carbocation. म्हणजे आतापर्यंत तुम्ही कोणाला मोर स्टेबल म्हटलं कार्बोकॅटायनला, तर ट्रायफिनिल मिथिल कार्बोकॅटायन हा मोर स्टेबल आहे. वाय? ड्यू टू रेझोनन्स इफेक्ट. And this is due to the aromaticity actually. म्हणजे aromatic carbocations असतील, they are always more stable. ते सर्वात जास्त स्टॅबिलिटी दाखवतात. ते even they are found in the solid state also. This is due to the more stability. Okay, this is just about the stability.